Okay, for number 2, again we have the question from chapter 1. Okay, the question is, the figure shows two forces F1 and F2 acted on a particle O. So this is where your particle O is. And determine the magnitude and also direction of the resultant force on a particle O. So for this question, we are going to get the resultant force. So what we do here is to resolve the force that we need to resolve. Apparently from the question, F2 is needed to be resolved and F1 is already in y-axis, so we don't need to resolve F1. So to have a proper solution, we have a suggestion here that we solve our question in a table because we have quite a lot of xy component to be determined. So we better have a table so that you can put the value in a proper way. So here in your table, for column, we have two columns, x component and for y component. And also we have two forces, that is F1 and F2. Okay, so what we do here, we put it properly in the table. So this is for x, for the left column, and for y, for the right side column. Okay, for F1x, okay, x component, F1x, we don't have any F1x component because F1 is already in y component, meaning that we have 0 Newton. And for F1y, we have 10 Newton. It is equal to F1. And for F2, okay, we to draw the x component that you have resolved and also y component that you have resolved. So this is the x component and this is the y component. So when you resolve your component, it's supposed to always goes to the nearest axis because this is our F2. So when you resolve to the nearest axis, so this is going to be your F2x directed to the left, and this is going to be your F2y directed downward. So when it is directed to the left or downward, it's supposed to be negative in the term of sign convention. So you have to put the negative sign here. So for your F2x, it is going to be negative. Okay, the equation here is, now we consider the sign convention. So F2x is equal to F2 cos 30, and it is negative. Okay, then you can calculate your F2 is negative 30 cos 30, and your force is negative 25.98 Newton. Okay, next for F2y, so the equation is negative F2 sine theta. So when we substitute the values, it's negative 30 sine 30. Then you'll have your F2y is negative 15 Newton. Okay. Then once you have got the x and y component for both forces, then we are going to total up. Okay. So this is the summation of Fx. So you add up the F1x and F2x. Then you are going to get negative 25.98 Newton. And for summation of Fy, it is negative 5 Newton. So to get the magnitude and directions, we are applying this equation. F resultant is equal to square root summation of Fx squared plus summation of Fy squared. Then you substitute the values in, 25.98 squared plus negative 5 squared square root, and your magnitude of resultant force is 26.46 Newton. Okay, for the direction, we are applying the equation of tangent theta is equal to summation of Fy over summation of Fx. So when you do the calculation, it is okay if you don't want to include the sign convention, so it's shift tangent 5 over 25.98, and you're going to get 10.89 degree below x-axis. So how do we know it is below x-axis? Because your summation of Fy is negative, okay, for the resultant. So meaning that for your resultant force, it is at this position, summation of Fx, and summation of Fy is also negative. So it is going to be at this position, downward. So your resultant is at this position, quarter number 3. Okay, thank you. That's all for question number 2.